Hi, welcome to a video on how to use the trace function and how to evaluate a function on the ti-nspire. For the purpose of this video, we are using example 5 from chapter 3, section 4 of Big Ideas Algebra 1. In this example, we are examining a problem where we have an awards banquet and we're renting tables. An equation will model the situation is in standard form 6x plus 10 equals 180, and we want to find the intercepts as well as 4 possible solutions to this problem. Now, in a previous video, I've already shown how to graph an equation in standard form. If you need details on how to do that, please watch that video. I'm going to assume at this point that we have already graphed this and we have it graphed on our calculator. Here is my equation, 6x plus 10y equals 180. Now, the window I've used here, I chose to use to go from negative 5 to 40, negative 5 to 30 with a scale of 5 in each case. I have the negatives here not because negatives are important. Remember, you can't have negative tables. That seems silly. But just simply so that on my graph I can see the line. If I don't have the negatives, the line's going to be on the edge of the window, which makes it just a little harder to see. So that's just more for being able to view. Now here, I really want to know my intercepts. I can kind of see what 1 is here. Hard to tell what this value is. So to find the intercepts, I'm going to use the trace function. The trace function can be found under Menu, Option 5, Trace, and we want Graph Trace. Graph Trace is great. It's going to give you values. Now, many will be decimals, but you can arrow left and right to get specific values. And as I go, I want to find that intercept to start off with. And it's going to take me there and even have the words y-intercept pop up. And I see my first intercept is 18. X is 0, y is 18. In the context of this problem, the y is large tables. So my intercept would mean I could have 0 small tables and 18 large tables. And that would be the y-intercept. To find the x-intercept, I'm just going to arrow the other direction until I get to the intercept. I'll know I'm at the intercept because one of these two values here will be a 0. And I'm right there, 30. So I can see, okay, 30, 0 is another intercept. That tells me that I could have 30 small tables and 0 large tables. Another great thing about having the intercepts at this point is I can easily graph that on a piece of paper, knowing it goes from 30 all the way up to 18 are two very easy points to plot. Use a ruler, draw a straight line in between, and you've got your line graphed. Now, the other thing this problem asked me for was 4 possible solutions in the context of this problem. There's a couple ways to find that. One way would be I can scroll down here, but if I use the trace button, it's going to give me decimals, and in this case, I really can't have 16.8 tables. I want integers. So I can't just choose any 4 possible points. I need to choose ones where I actually have a integer. So in this case, 5, 15 is a possible solution. 5 small tables, 15 large tables. If I keep going up, 10, 12. 10 small, 12 large tables. So these are all possible situations or solutions in this scenario. I also said I was going to show you how to evaluate. Evaluating a function is really easy. So let's say, for example, I want to know what is the value when x is 20. All I have to do is just start typing the number 20. Now I have to be in the trace function for this to work. If I hit escape, I'm now out of the trace function. I type in 20, it doesn't do anything. If I return menu, trace, graph trace, I'm in trace function again, and I type in the number 20, you'll notice that a little box appears here with an x equals. I say, no, yeah, x equals 20. I want to know what happens when x is 20. I hit enter. 26. 6 is an integer. Okay, so that tells me when there's 20 small tables, there are 6 large tables. And I can do this with any value. If I want to know what is the value when I'm at 26. When x is 26, y is 2.4. This is not a possible solution in my word problem. I can't have 2.4 large tables. I can't cut a table into pieces. I guess I could, but that wouldn't be relevant to this problem because then I no longer would have a standing table. So, again, to evaluate, you just type in the value once you're in the trace function. Again, the trace function, really helpful for all sorts of scenarios, whether you need to find specific solutions like we did in this problem, or whether you want to graph and you want some specific points in this case. Now, a helpful note, when you are graphing in standard form, you might think to yourself, oh, I'll just get a table of values. Or if a table of values does not work, that your table It does not work when you are in standard form. It's going to give you this little pop-up box. Because standard form is not function notation, so it doesn't identify it as a function for you. So the trace option is really the only way to get specific values when you are in standard form.